Hi friends, today we are going to conduct a no load and block rotor test on single phase induction motor. The aim of this experiment is to find out the equivalent circuit parameters by conducting this no load and block rotor test. And the specifications of this induction motor are, so here from the nameplate details we can take the speed here, RPM 1450 RPM and the 50 Hz, and the capacity of this motor is 0.75 kilowatts or HP, and the rated current of this motor is 6.6 amperes and the power factor is 0.72. So the circuit diagram for conducting the no load test is here. Now we'll connect the circuit as per this circuit diagram. So here this is a single phase supply, DPST switch, and single phase variac, and this is an induction motor with the main winding and auxiliary windings. And this is the rotor of this induction motor, and voltmeter and ammeter, and next this is a wattmeter. The connection diagram. So here the single phase supply is connected to the single phase variac, input of this variac, and from this the voltmeter is directly connected across the output terminals, here the voltmeter is directly connected. Now from the phase terminal it is connected to the ammeter common point. So this is ammeter common point, and next from the 10 amps terminal, now it is connected to the main terminal of the wattmeter. Now M and C is a common point, these are short circuited, and now from the L point it is connected to the motor line terminal, and next from the neutral terminal of the motors to the neutral terminal of the variac. And one more connection here, this is connected to the voltmeter negative. So this completes the connection diagram for the no load test. Now this circuit is started with the help of DPST switch. So this switch is closed and the variac is varied gradually so that the voltmeter reads the rated voltage of 230 volts. So the variac is gradually varied so that the voltmeter reading is 230. Thus we have ensured that the belt is loosened completely so that it is under no load condition. Take the readings of voltmeter, and voltmeter is showing 230 volts, and the ammeter current it is 4 amps, and next take the reading of wattmeter. This is around 40 watts. This is less than 50, it is 40 watts. Now we have to take the multiplication factor for the wattmeter. So here this is connected for the parallel connection, and the voltmeter is 300. So for the parallel connection the current coil is reading 10 amps. Now the voltmeter is connected to the 300 point, so the multiplication factor is 4. So we have to take these readings and note down these readings on the observation table. So this is a observation table. We have to note down these readings here. Now bring back the variac to the minimum position. And this is made to 0. Now open switch. Now we will conduct the block rotor test on the single phase induction motor. So this is the circuit diagram for the block rotor test. Now here we have to completely block the rotor with the help of breakdown belt. Block the rotor so this will not be rotated. So it is completely tightened. So now we are conducting a block rotor test. So the connections are made similar to the circuit shown in figure. And now we will start the motor with the help of this DPST switch. Now vary the variac. The variac is gradually adjusted so that the current reads the rated value. So the rated value of the motor is 6.6 amperes. So we are increasing up to 6.6. Now take the readings of voltmeter, and here this is the ammeter reading. Then note down the reading of wattmeter. Again this is connected in a 750 scale, and this is a 300 volts. So the same multiplication factor is 4 only. So here 10 amps and 300 volts. The multiplication factor is 4 only. Now then bring back the variac to the normal position so that this voltmeter and ammeter readings are 0. Then open the DPST switch. So this completes the. So now we'll record the readings. From the no load we are getting 230, 3.9 and 200 watts. For the block rotor test we are getting the input voltage of 58, and we are applied the rated current 6.6, and we are getting the voltage of wattmeter reading of 90, and this will be multiplied with a 4. It's a multiplication factor. So this is equal to 360 watts. So these are the readings which are obtained from the no load and block rotor test. Next we will do the model calculations by using these readings. So these are the model calculations done by the taking the readings under block rotor condition. So the voltage wattmeter reading is 360 watts, and the current is 6.6, and the voltage is 58 volts. And then the rotor resistance of an induction motor under block rotor conditions is RSC, which is equal to WSC by ISC square. So just substitute this, you will get the value of 8.26, and then the impedance is VSC by ISC, so we'll get a value of 8.78, and then the reactance of the winding XSC, which you can obtain from the under root of ZSC square minus RSC square. So you will get the value of 2.97, and from this we can find the reactance of the stator winding and the rotor windings, so which we are obtaining as a equal values on the stator and rotor. That's why we are taking the values of half of the value. So this is 1.489 and 1.489. Similarly the resistance also we are assuming it is equal. And now from the no load test we are getting the readings of W0, V0 and I0. Then no load power factor can be obtained here. Then the voltage across the output terminals VAB can be obtained by using this formula. Then by substituting these values you can get these readings. So you can calculate here, and then the VAB which is obtained here is 233.56, and the X0, the no load reactance, can be obtained as VAB by I0. So this is a no load equivalent circuit of the induction motor. And next this is a equivalent circuit of a rotor under block rotor conditions. And next one is the complete equivalent circuit of an induction motor. So this is a VAB. So this is an equivalent circuit of a single phase induction motor. So with this we can draw this by using a no load and block rotor test. Thank you.